So law sines, law cosines will be the second day. Will be Wednesday because that you need calculators for, right? Okay. You really don't, but I'm gonna let you. You just got. That would be gross. I need you over there. Anything else before we get into new stuff? Our last new stuff of the semester. Let me say this real quick, because I know a few of you guys are thinking about taking 180 next. Some of you guys have already signed up for some stuff. If you're taking 180 over the summer, cool. That's a really good idea. Because I've taught it over the summer before, and I get really good retention, really good grades, and I think partially the math department realized this a long time ago, and we kind of redid some other stuff based on this, but there just isn't enough time to forget stuff. Right, we meet Monday through Thursday for 6 weeks. So in this kind of class, we meet Monday and Wednesday, and there's so much time between Wednesday and Monday to just forget stuff. You guys kind of with me? I'm sure you guys have experienced this. There's just not that much time to forget stuff. I'm always curious what the long-term retention is. The short-term, it's great. If you take 180 over the summer and you're planning on taking 280 in the fall, or if you're taking 180 in the fall, there is a class called 180L, 280L, which is this kind of extra little side course. It's a lab course, which is what the L stands. There's no homework for that class. It's just purely in-class help with prerequisite knowledge. So like a review of trig when you need it as you hit trig stuff in 180, 280. Are you guys at all with me? So there's going to be a mixture of Calc 1 and Calc 2 students in there, but we're all going to be talking about trig, we're all going to be talking about factoring, whatever the hell comes up. Does that make sense? So consider that option if you have time. It's 12:30 to something. It's like, I can't remember how many units it is. 1.5 units or something silly. Can't remember. You guys are kind of with me? So that's 180L, 280L in the fall. You can consider to take that or not. You don't have to. Okay. If there's nothing else, everybody's kind of cool with our immediate future? Hey.
Even if we're not alone.
Pretty much, but when I say cool, I mean understand. Everybody understand what our immediate future looks like. Okay. Let's see. George's not here. Alex is not here. Christian is not here. Brandon. Sorry about that. And Kai. Yeah, your little dudes are, they just fall over, so I don't pretend. All right, thank you. You made me consider changing my syllabus to include standard-sized paper only, please. All right, guys. So this is the last brand new stuff. So we can have a little celebration. So there's two things I want to talk about today. I'm going to talk about complex numbers. How much do you guys already know about complex numbers?
You mean imaginary?
Imaginary, yeah. Complex numbers have a real part and an imaginary part. So every number you've ever seen ever is a complex number. 7 is a complex number. The real part is 7, the imaginary part is 0i. You guys kind of with me? Okay. So let me ask you this. Anybody know anything about imaginary numbers just by themselves? Yes?
They relate to 3D shapes.
Sure, a lot of the math we do relates to 3D shapes, but more fundamentally, yeah.
The square root of -1. That happens when you square root a negative number.
Yes.
They're not on the coordinate one. They're not like on the x-axis or the y-axis.
Yes, they're next to it. I love it. That kicks ass. I might
They're just on the graph. There's no like real points on the graph that is on there.
Well, let's see. Okay. So real quick. This is going to seem a little silly. When I have a number like 1, and I multiply it by -1. Right, so we're getting really, really, really deep. Because I'm going to talk about 1 times -1 for a little bit, which is weird. when I multiply a number times a negative, what that means visually is I'm rotating around 0. Does that make sense? 1 times negative 1, sure enough, is negative 1. You with me? So when I multiply by negative 1, I'm just rotating. So what's negative 1 times negative 1? I would start here, and I would rotate. So what is negative 1 times negative 1?
1.
Holy shit. Okay. So that's the basics of multiplying by negative 1. I just rotate around. What's the square root mean? What's the square root of 9?
3,
Why?
because
Like,
three
3 times
times
3 is 9.
So would it make sense? Because we haven't really done, we've done some with square roots, but I don't think I've said this. Half of 9 multiplicatively.
Yeah.
So what's half of 9 additively? 4.5.
4.5.
Because 4.5 plus 4.5 is 9. What's half of 9 multiplicatively? 3. Because 3 times 3 is 9. You guys all with me? So when I say half multiplicatively, that's what I mean. So if I want to rotate halfway, I want to do half of a negative 1.
It's odd.
Square root of 9 is half of 9, correct? Multiplicatively. So square root of negative 1 is half of negative 1, multiplicatively. You with me? Now, it got a really bad name. We define this to be I. I stands for imaginary. If you go into electrical engineering, they don't use I, they use J. Because they just want to be different. They don't like math people. I took an electrical engineering course because I couldn't get it in my physics, so I had to take it with, I was the only physicist in the sea of engineers. And then I'm like, this shit is J. What do you people do?
What's wrong with you, man? It's Jay.
So, how many guys have never talked about this before? I think most of you should have. Maybe you've forgotten, but does everybody remember talking about this basic idea? No? Okay.
Yes.
Does it make
Not to.
any sense at all? A little bit. I like the visual. This is something that I was never shown. I learned it much later in life. And I'm like, why the shit did no one ever show me this? So it got a bad rap. Back in the day, we thought negatives didn't exist. People called negative numbers imaginary. And I'm sure you guys all understand this. When I was in grad school, if negative numbers didn't exist, the bank would have no way to represent what my balance was. So we all know negative numbers exist, unfortunately. But can you imagine, like, back in time, they didn't think negative numbers existed. What's 3 apples minus 4 apples? The anti-apple, right? So there are problems where negatives don't make sense, of course. You can't build a negative 5 foot by negative 3 foot shed. I don't want to go in that shed. What the hell is that? But there are problems where negatives, negative degrees, negative bank account, negatives make sense. This really tripped people up. And the name stuck. The name imaginary stuck, which is unfortunate because they are not imaginary. They exist. They do exist. They do exist. Okay. I think I do want to show you this video. It's going to take a little while, but too bad. This video kicks so much ass. So let me ask you this while I'm looking this up. What is I squared?
-1.
It's the first thing we've ever squared, and the answer came out negative, correct?
Yeah.
That is one of the most fundamental things about complex numbers, is that when I square them, they can come out to be negative. All right, let me see. Go to the YouTubes. On the internets. All right, let's see. Imaginary numbers exist. There it is. All right, let me see. Is everything set up here? I should stop recording so I don't get copyright strike. Let's talk about what we have to worry about. So I just wanted to give you that video because the name sucks. Students are like, yeah, I know you make all this shit up, and now you're just being more honest about it. But they're not made up. They're just a bad name. So coming back to this. just in case I heard somebody say they didn't really understand something a second ago, what is the square root of 7 squared? What does the square root of the square do?
Cancel.
So that's 7, correct?
Yeah.
So what's the square root of negative 1 squared?
Negative
One.
one.
Negative 1. So I squared is negative 1.
Yeah.
I to the first power is I. That's crazy. What's I to the 0 power?
1.
1. I love it. What's I to the third power? How the hell would you figure that out?
Just do 1.
Huh?
You do 1 times rad negative 1 to just get.
No. So I think I'm not sure what you're doing. So wouldn't I just multiply this by one more I to get I cubed?
Yeah.
So what's negative 1 times I? What's negative 1 times anything? What's negative 1 times 3?
Negative 1.
What's negative 1 times 3?
Negative.
What's negative 1 times 7?
Negative.
So what's negative 1 times I?
Negative 1.
Okay. And what's I to the fourth? Smart way to do this is it's I squared times I squared. Negative 1 times negative 1, 1. Now here's a visual of what the hell I just said. If I don't turn it all, if I start at 1 and I don't turn it all, isn't that 1? I don't go anywhere, that's 1. So that's I to the 0, no terms. If I take half a turn, really a quarter of a full turn, but that would be I to the first, that's I. Another half turn is negative 1. Another half a turn, if that's I, what's down here?
Negative 1.
Negative I. That's here. And then if I take another one, I'm back to where I started, and that makes 1. I like it. Yes?
So, wouldn't I cube just be I?
No. Again, I times I is I squared, I times I is negative 1. I squared times I is I cubed, negative 1 times I is negative I. So if I just keep multiplying by I can kind of move up the exponents. So if I multiply this by I get I cubed. If I multiply this by I get negative I. So therefore I cubed must be negative I.
But if I equals negative, square root of negative 1, wouldn't the negatives cancel each other out then?
What negatives?
The negative of the square root of negative 1?
No, okay. What is 3 times the square root of 2? Can you do anything? Is that the square root of 6?
No.
No, of course you can't, because this doesn't have a radical on it. So it's negative 1 times the square root of negative 1. Do the negatives cancel?
No.
Of course not.
Okay.
Same reason you can't do 3 times 2. Yeah.
Okay.
Okay. Now I understand what you're saying, but you see, yeah, you gotta be careful. Alright. I do sometimes get students that start to think this is true, and there's no damn reason we would ever do that. We're cool with negative 1. We don't have to give it some letter. This, we don't want to look at. That freaks us out, so we decided to call it I instead. Okay, how we doing? Okay. So for example, if I were to solve this, what would I do? Take a square root. When I take a square root, what do I put?
Plus or minus.
Plus or minus. So I get x is plus or minus 2. Before today, you could not solve this. Even though the fundamental theorem of algebra says there must be 2 answers. Fundamental, FTOA, the fundamental theorem of algebra says whatever the highest degree is, that's how many answers you got. Period. No questions. Before today, you would have said there was no solutions. That would make no sense. There's got to be 2 answers. Got to be 2 answers. Now I know what they're going to be. What's the square root of 4? 2. What's the square root of negative 1? I. I am the alpha and the omega. You guys semi with me? So basically, whenever you take a square root of a number, if it's negative, an I is going to show up. Yes?
It doesn't help that throughout schooling and whatnot, we're taught, when you multiply a negative number times a negative number, it equals a positive number too.
When you multiply a negative real number times a negative real number, that's what they should have been saying.
Yeah, even if it's like a decimal or a fraction, it still turns into a positive number.
Yep.
So there's no way we would have thought that.
Yeah, and again, it's just, we have to be careful how we speak, and sometimes we don't wanna say real number, because then it starts to be, well, what's the other stuff, and we're like, we're not ready for it. I think we should teach imaginary numbers way earlier, but, you know, we don't. It's too bad. So that wouldn't be so freaky now. If you learned French when you're 2 years old versus when you're 18, it's much easier earlier, so I always like to push math back earlier, but, oh, well, we're never gonna do it. Yes?
So I is a real number, right?
I is officially not a real number. It's just, and again, that's just a name. Doesn't mean it doesn't exist. It just means it's not in the category we call real. So the name real was a bad choice too. So of course we had the reals and the imaginaries. We shouldn't have called them that. What should we call them? I don't know. The mains and the laterals, maybe. Maybe. So does anyone remember how to solve this equation here? Let's see. Yeah, we'll do that.
Complete this group.
Yeah, you could, but let's not do that. What's the more direct way to do this? If you try to factor this, can you find factors of 5 that add to be 5? No. So when you have a thing like this, you can't factor it. Use good old quadratic formula. Well, how's a quadratic formula work? So this is A, this is B, this is C, right?
Yep.
X equals
-5.
negative B.
Plus or minus square root of E minus 4 times A times C. All over 2A.
Good. So then I get -5 plus or minus the square root of 25 minus 4 times 1 times 5 all over twice 1. So this comes out real, yes? Now if I make one little change, let me think, is that gonna work? Yes. Try to factor that, it won't work. 5 and 1 had to be 6, not 4s, yes? So I have to use quadratic formula again. So just to cut to the chase, be negative b plus or minus square root of b squared minus 4ac divided by twice a was 16 minus 20. Negative 4. So you get negative 4 plus or minus, what's the square root of 4?
2.
What's the square root of negative 1?
2. So I.
And then I can cut both of those in half. You get that?
I'm just looking at, you just treat I as just a variable like that.
Yeah, I, on one level, it's just a variable. I can't combine it with 2 because they're not like terms. 2 plus x is 2 plus x. 2 plus I is 2 plus I. A kiss is just a kiss. No. Yes.
So let's say you have like something like other numbers besides 4, like say
Sure.
square root -16 or -32.
Oh, sure. So,
Like,
all right, let's just
would
focus on that.
would it always be with
How would I do this?
4i.
So I get the square root of -1. 32 you can break up, yes? We've done this before. 16 times 2. Square root of 16 is
4.
4. Square root of -1 is
I.
I. Square root of 2 is, I don't know.
Yeah,
You always have I next to it.
If it starts off as a negative inside of a radical, there must be an I at the end.
Gotcha.
Because I is the square root of -1. That's what I do be. I love it when we start talking about imaginary numbers, it sounds like my grammar gets really bad. I is the square root of -1. That's what I is. Yes?
So what if, instead of square root of 16 times square root of 2, what about doing square root of 8 times square root of 4?
Yeah, then you would just do it in 2 steps, right? So if you did I, square root of 8, square root of 4, so you'd I, 2i times square root of 8, 8 is 4 times 2, so you have 2i square root of 4 square root of 2, which is 2 times 2 is 4i square root of 2. You eventually get there. You see that? You have to do it in 2 steps. Sort of like reducing a fraction. If you don't think about the right number in the first place, you might have to do it a few times. So it's okay if you don't get this set up. You just go, oh shit, 8 goes further. Okay, take 8 further. No big deal. Okay, I like it. How you guys feeling? Yes?
If you were to backtrack to the problem above, yeah. Oh shoot, never mind. I was like,
I like
I bet I missed that.
So, little side note. How do you factor x squared minus 9?
X minus 3, x plus 3.
X plus 3, x minus 3.
Yeah, either way. 11. How do you factor x squared plus 9? Before today, you could not. You cannot factor this with real numbers. But you can factor it all day with imaginary numbers. So, real quick, why does this work? Because they have to be opposite signs, so the middle term cancels, and if they're opposite signs, they have to multiply by negative. Not imaginary numbers though, right? Let's check this shit. X times x, x squared, crazy. Do you see how the middle terms cancel? Is that cool?
Yeah.
And then what's 3i times negative 3i? That's negative 9i squared. Is that cool?
Yeah.
What's I squared?
Negative 1.
There you go. That's what it is. It's x plus 3i, x minus 4. So now you can factor sum of squares, which I know is keeping you up at night. I'm gonna be able to do it. Finally, Mr. Walsh. Okay. I understand. Okay. It's not too much more to complex numbers. Well, what do you guys think about here's a complex number. We call it a complex number because it has a real part. What's the real part? Holy shit, what's the imaginary part? Crazy. So any combination of real and imaginary, we officially call it complex. Every number you've ever seen, 7, is complex because it's got 0i. It's got a real part, it's got an imaginary part. I like it.
Okay.
So, what is 3 plus 4i minus 2 minus 7i?
Ooh.
1 plus 11i.
What can you do with a negative? I'll tell you what to do with a negative. What can you do with a negative? Distribute, so you get 3 plus 4i minus 2 plus 7i, and then you get
Plus
1
Plus 11.
plus 11i. Done! Easy shit! So when you're adding complex numbers, it's silly. I is just a letter, it's just like a variable. Now, yes,
I just want to say, if you have 11 eyes, you might want to go see a doctor.
true. I'm not sure if that'd be good or bad. Probably be bad. As a teacher, it'd be good to have a couple. So what if I do this? What's your gut instinct tell you? Let me do the same problem. 3 plus 4i times 2 minus 7i. Well, it's already
I mean, FOIL.
FOIL, right? Go ahead, do it. I'll sit here and do nothing. Start to catch up to you. Did I restart this? I think I did. Yep. So you get 6.
6 plus 8i. 28i squared.
Minus 28i squared. So it feels very much like it's just an x. So in the middle I can get what?
6i.
Or negative 6i.
No,
No, you get negative 13.
13
Oh, no, i's.
And then plus 34.
minus 28 times, what's I squared?
Negative 1.
Negative 1. So I get 6 minus 13i plus 28, so I get 34.
Minus 13.
You see how I started with two complex numbers multiplying each other? How do you know this is a complex number? It's got
Imaginary and real.
a plus bi. Did I end up with a complex number? Yep, a plus bi. So two complex numbers add to be a complex number, they multiply to a complex number. We call that closed. Complex numbers are closed. They don't become a different kind of number when you multiply or subtract or divide them. Let's talk about division real quick. I don't remember if this is in there. Does anyone remember how to handle this? Let me see if they have that.
Break it up.
Should, huh?
You could break it up and then.
No. Can't break it up. Can't break it up when there's more than one thing on the bottom.
Can you not do 1 over rad 2 minus 1 over 3?
Definitely not. So desperately not. I don't think they do this. No, there it is. They do. So be really careful. I could break it up if it was square root of 2 minus 3 over 1. I could break it up, of course, right? But I can't break it up when it's over two terms. I cannot do that. Is 1/5 minus 1/4 equal to 1 over 5 minus 4? Is that true?
No.
Hell no. Okay. So let's see if anybody remembers this. I would multiply by what's called the conjugate. On the top here, I'll do the top. Whew, okay. What's rad 2 times rad 2? 2. See how the middle terms cancel? Minus 3 rad 2 plus 3 rad 2, is that cool? And what's negative 3 times 3?
-9.
So did I make the bottom become a rational number? Yes. So I don't know, does anybody remember doing this kind of thing?
Yeah.
Somewhat? So
Very
therefore,
beginning of college algebra.
totally. Therefore, how do I do this?
Multiply by 2 plus.
Yeah, all I is a radical. That's all I do be. So we multiply by the conjugate again. Not surprisingly, this is called a complex conjugate. Ooh. All conjugate means is same terms, different sign in the middle. That's all it means. If I do that, the middle term where the I would still be alive dies. Do you guys see that? The middle term is the only place I could still have some I's, and they die. So on the top, I'm going to have to worry about this. Let's worry about the bottom first. What do I get? I get 2 times 2. Holy shit. Negative 5i times 5i is minus 25i squared,
Plus 25.
which is plus 25. I love it. Just to cut to the chase, you guys could FOIL. I know you can FOIL. So it'd be 6 plus 15i plus 2i plus 5i squared, which is minus 5. So I get 26 plus 10. No, get out of there, Jeff. I get 26 minus 5 is 21 plus 15i over 29. Just getting like terms together. Okay, maybe. So don't let the I stuff be too funky. It's not too bad. Okay. This is the worst kind of problem I think you'll see. It's just got the most work to do. But if you just remember I squared is negative 1, that's the only thing that's new. Anything else looks just like normal foiling. But the minute I get to my I squared, I can replace it with negative 1. Yeah.
Would there be times where you were giving, where you're given like I cube, I to the 4, stuff like that when
Sure.
you're trying to solve it?
Yeah, real quick word about that. I to the 4th was 1. I to the 0 is 1. So what do you think I to the 8th is?
One.
Yeah, every 4 it repeats. So it goes 1 I, negative 1, negative I. 1 I, negative 1, negative I. Okay. So therefore, if I had I to the 33rd, what number is right below 33 that 4 goes into?
32.
I to the any multiple of 4 is
One.
1, because that's a complete trip around, yes? Ah, bam. Another way to do it is I to the 806. 4 goes into 806, I don't care how many times, how many left over? 2 left over. 804 would go into perfectly, yes? So it's going to go 804 times around, and then 2 more times around. So this is the same thing as I squared, which is negative 1. Done. Easy shit. So if you just take the power, divide by 4, see with the remainder, you can see where you are in the cycle. 1, I, negative 1, negative I. 1, yeah, okay. Yes?
Sorry, what did you call the numbers that like they cancel the middle terms out?
Oh, this is complex conjugates. Yeah, they're kind of like a difference of squares pair. Yeah? Okay. All right. So that's all there is on complex numbers. Just got to get in there and try those out. Last new idea for the whole semester. You're going to love this. Okay. Let me do it over here. Do you guys agree that this is roughly like an XY, your chairs? Right?
Sure.
Oh, I'm losing something. So like if I go 3 chairs in and 1 chair over, right? Or if I go straight down, like, right? I can get to different people in the classroom by going so many in, so many over. You guys got it with me? But I could also, so do you guys agree this would be like the y-axis?
Yeah.
I'm at 0, 0 right now. So if I move over left or right, that's the x-axis. Alright, so if I'm here, I'm looking right at the x, right along the positive x-axis. You with me? So one way for me to tell somebody to get to Daniel is to go 1, 2, 3, 4 chairs up and 1 chair over. Then I get to Daniel. Right? Another way I can tell somebody to get to Daniel is stare at 0 degrees. Right, the x-axis is 0 degrees. Rotate by so many degrees, and then walk out so far. So the thing the x-y axis did for us is it helped us locate objects in 2-dimensional space. So another place we use it is, of course, on the Earth. And this is where flat earthers get excited. See, I told you it's flat. No, shut up. So on the Earth, we've overlaid these curved latitude, longitude, correct? So if you're out at sea and somebody's trying to find you, you can tell them what lat and long you are. You guys all a little bit, okay. So that's the idea of XY planes, just put on the Earth. Okay. I could also tell somebody, so to get to a point, we do it up here. It doesn't matter, Jeff will stay up here. To get to a point, I could tell somebody to go over so much and up so much. That would be XY. Crazy sauce. Or I could tell them, rotate by so much and then walk out so far. This would be theta. Remarkably enough, we're going to call this one R. Okay. You guys semi with me so far. So I really need you to understand the XY coordinate system is one option for locating points on a plane. That's one option. It's fat. Is anyone going to like Calc 3 eventually? Is that in anybody's future? Calc 3, you start to realize how many coordinate systems there are. I have used, in my lifetime, I've used upwards of 15 coordinate systems. X, Y, R, theta, you got spherical coordinate systems, you got cylindrical coordinate, holy shit, you got a stupid number of coordinate systems, it's insane. So you start to see a couple of them in Calc 3, beyond the normal stuff we use. This is called the polar coordinate system. So for example, I'm gonna give this to you in a minute, but I'm just realizing I didn't bring any blank things. It sucks. I gotta remember to put up in Canvas for you guys. The way the polar coordinate system looks is it's a bunch of circles, and then it's a bunch of angles. So let's say these are the ones we know for sure. So if I have the coordinate in polar coordinates, so if I have the point 2 pi over 3, what that's saying to somebody is rotate to stare at pi over 3, and then go out 1, 2 steps. So that would be the point 2 pi over 3. Yes?
So it's r comma theta, right? That's-
Yes, good. So it's r theta. I kind of wish we would have made it theta comma r, but I wasn't around. I'm not quite that old. This is going to kick so much ass. I think you guys, it's nice to kind of find polar points and plot them. They just kind of make sense, yeah.
So, the r comma theta, that's just the Arclay formula.
Yeah, you were going to see a lot of old standbys. For example, if I know x and y, I know x and y. How would I figure out r? I know x, I know y. How do we get r? So you guys know.
Of x squared plus 1 squared.
Yeah, r squared equals x squared plus y squared, yes.
Yeah.
How would I get theta?
Inverse tangent.
Yeah, beautiful. Inverse tangent of
X squared
y over x.
or y.
You guys with me? Now let me ask you the other way. What if I know r and theta? How do I figure out x?
You do inverse.
What's cosine of theta from this triangle?
X over r.
So what's x?
R cosine theta.
X is r cosine theta. What do you think y is? Go to the chase. X is r cosine theta. Y is r sine theta. Again, this is old shit. We know sine theta is y over r, and this is just solving for y. This is old shit. We're just using it in a different way than we did before. So let me give you this paper. And if I remember, I've got to remember, so maybe somebody should remind me. I have like blank polar graph paper that I can put up in Canvas so you can print it out.
Oh, yes.
You could also just Google polar graph paper, but it took me a while to find this one. This is my favorite one that I found. I'll get you mine.
Thank you.
So, guys, at the top I have put in blood red, I've put the transformations we just talked about. These are translations between polar and rectangular. Are you guys with me? So for example, let's do this first. Look at the bottom in here. What is this point telling somebody to do? Where am I supposed to look?
It's rotate pi to 3
Rotate till you're facing pi over 3,
and then walk 3.
and then walk 3 out. 1, 2, 3. So it's, yeah, okay. I should put my glasses on. What's really cool about this, can you imagine? This is so weird. We've never seen a coordinate system where one of the things is a circle. But if I take the xy plane, can you imagine? Here's the xy plane. Everybody see it? And I curve it. It's that. So I curve, so all the y lines, I curve them so they meet. Bam! That's what I get. It's crazy. Okay. So what's the second point tell you? Oh, by the way, real quick. Oh my God. When you're plotting several points, dear God, label the shit out of them, yeah. I get people turn stuff in, it's just point. Oh. Where's this guy? Where do I face? Here, let's not say anything. Don't say anything. Try to graph the next few, and then I'll catch up to you. So you can define the circle axis, right? The R axis. You can define the circles to be 1, 2, 3, or 2, 4, 6. So I decided to do 1, 2, 3 because none of the R's get bigger than 4. You guys kind of with me? And it's a nice visual. They did the blue line. It's like the 5th step out, just to make it easier to count out there. Yeah.
Are you supposed to go negative if it's always going outwards?
We'll talk about it.
You start from the high level.
No, we'll talk about it. So part B, I'm gonna face
3 pi over 2.
3 pi over 2. I'm gonna face south here, and I'm gonna go out. I'm gonna go forward. 1, 2, 3, 4 steps. So there's that one.
Oh, I need to just go back.
Yeah, negative is back. 3.5, not a big deal, right? Not ideal, but too bad. 3.5, so I'm gonna face pi. I'm gonna go 1, 2, 3 and a half. Same thing with D. Face pi over 6. And go out 1 and a half. Now here's the one you were asking about. Face 2 pi over 3. Face that way from the origin. Face it and then go backwards. So what really sucks is these lines are hard to tell where they go on the other side. But of course it's going to go to the other over 3, the reference angle. So if I'm facing 2 pi over 3, I'm supposed to go back 3. I just face 5 pi over 3 and go forward. 1, 2, 3. So based on what I just said, what's another name for that same point?
3 pi over
3,
5 pi over
5 pi over 3. I love it. How many other ways are there to identify any polar coordinate? How many ways is there to identify 10 degrees? No, the infinite number, right? I can add 360 as many times as I want to. I can subtract 360. Remember the plus or minus 2 pi k? 2 pi k. Yes.
Would that make it like a reference point?
Oh, it's related to terminal angles, right? Remember terminal angles? That's what I was just basically saying. Like 45 degrees is coterminal with 405 degrees because you go 360. Is that cool? That's basically what that is. I could take any point, like A. How do I write this with a negative R instead? Point A. Where should I tell somebody to face if I wanted to go backwards 3? 4 pi over 3. Good guess. So there's an infinite number of ways to write it with negative R, and there's an infinite number of ways to write it with R. Yes?
So you add or subtract just pi to the data to get.
If you're changing the R value from positive to negative, is that what you mean?
Yes.
Yes. Cool. Totally. What about this guy? So of course this one I'm rotating which way? The angle tells me to go
Negative 11.
Negative.
12,
So where am I actually going to go?
5 over 12.
How far short of pi?
5 over 12.
Pi over 12 short. So I'm going to actually be looking at 13 pi over 12, yes? If I go back 11 pi over 12, I don't quite get to pi. So I stop pi over 12 short. And then I'm supposed to walk out 1, 2. So that's F. Yes?
Wait, but aren't we facing negative 11 pi over?
Yes, we're facing negative 11 pi over 12. This is negative 11 pi over 12.
Oh,
Because I go back 11 pi over 12, so I stop pi over 12 short. So I'm looking right here. That is negative 11 pi over 12. Okay. Yes?
Another way to remember, like the negatives, like say negative 11 pi over 12, you're just going backwards instead of
Yeah, yeah,
when
of
you're
course.
going clockwise instead of going.
Yeah, yeah. From the very first or second day, we talked about positive angles go counterclockwise and negative angles go clockwise. Totally. All right, so look up here.
Come back.
Come back. Thank you. Convert two rectangular coordinates. So, what is 2? Convert two rectangular. So is this xy or what is this? This is r theta. So how do we get x?
R cos.
Yeah, r cosine theta. So this is a perfect problem to do by hand. When I give you an angle that you know, what's the cosine of 5 pi over 3? I think I heard it. Five pi over 3. What quadrant am I in?
Oh, sorry.
What quadrant's 5 pi over 3? Fourth quadrant.
Negative 1.
Yeah. I'm a third of a pi short of 2 pi, yes. 2 pi is 6 pi over 3, so I'm a third of a pi short of 2 pi. Sounds about right for me. Fourth quadrant, so cosine's going to be positive or negative?
Positive.
Positive. So screw the 5 pi over 3. Now if you're thinking about reference angle, what's the cosine of pi over 3? Cosine likes x, doesn't like y. So pi over 3 is way close to y, yes? Pi over 3 is 60 degrees. Yes?
Yeah.
What's the cosine of 60? 1/2. So it's be twice 1/2. That's crazy. Y will be 2 sine of 5 pi over 3. Sine is positive or negative in the fourth quadrant. Sine is positive or negative in the fourth quadrant? Negative. And the sine of 60
Negative rad 3
times 2, so the 2's cancel. Is that cool? So this would work the exact same way. I'm not gonna do it. You would just do negative 12 times cosine of 7 pi over 6 and negative 12 times sine of 7 pi over 6. Same way. Now I know this is very new to us, but anywhere in the universe that I see r times sine theta, that equals y. From polar to rectangular. You guys with me? So what's missing in front of the sine for me being able to change it directly back into xy? So I want to go right back to rectangular, xy. What do I wish was in front of the sine? R. If only there was an R in front of that, wouldn't I be able to just put a y there? There is no R there, is there? So you're like, he must have made a mistake. I think he meant to put an R. No, screw it. How do I make an R show up in front of the sine? What do I do to both sides? Multiply by R. So this side becomes R squared. And like we said, what's R sine theta?
Sine theta.
Y. And what's R squared? X squared plus Y squared. So is the equation, does it only have X and Y, no R theta? Does this equation only have X's and Y's, no R's and thetas? So I'm done. I got it into rectangular, which means X's and Y's. What about this one? What the shit do I do with this thing? Now, if you take sine or cosine, that's going to suck because then I also need an R. But what's tangent theta? Y over x. So can't I just take tangent of both sides? Tangent theta is y over x. What's tangent of pi over 6? Who remembers?
Rad 3 over 3.
Rad 3 over 3. Jeff, you can do it, buddy. There you go. So by the way, let me say this. Let me go. Jiminy Jeebus. Okay. Let me go one more step. If I multiply the x up, what does that look like? See, I multiply the x up. Doesn't it look like y equals mx plus b? B is 0? You guys with me? Isn't this a line? What's the slope of the line? Rad 3 over 3. So in calculus, you're going to talk about tangent lines. Tangent lines are lines that have the same slope at a certain point as the original thing did. Just go straight. This is why we call them tangent lines, because the tangent is the slope of the damn thing. Don't know if you guys are... Okay. Yeah.
Just to backtrack a bit to 2A. Yeah. So how did you do it to where it's r squared?
And multiply both sides by r.
Oh,
Why did I multiply? Because I knew I want an r here, so then it becomes y.
gotcha.
Yeah.
Okay, I just got confused. on
Yes.
Can you go to A again?
So A, what, 1A or 2A? What?
Wait, where did you like put that as a for the y equals 2 sign from 5 or 3?
Yeah.
Where did you get that?
What do you mean?
Like
What's r? What's r?
it's 2,
2. And what's theta?
it's 5,
And what's y?
r 7
So r 2 times sine of theta, 5 pi over 3.
Oh, so you have to do.
If I know r and theta, this is how I convert back to x and y.
Oh, and then you have like actual numbers, right?
Yeah, then I can just figure out what it is. Yeah.
Oh,
Yes.
Really quickly with 2B, what the simplified answer, do you want it to be y equals root 3 over 3x?
No, I circled this because that's fine to stop here. I went one step further just to make more general point. Yeah, so I would accept either one. Yeah.
You would accept either one?
Yep.
Okay, cool.
All right. Let's talk about this one. This says convert to polar, so it's currently xy. How would I get r if I know x and y? Yeah, x squared plus y. So r squared equals square root of 3 squared plus 1 squared. Square root of 3 squared is 3. 3 plus 1 is 4, so r is 2. And how do we get theta?
dude.
So another way to write this is solve for theta.
Inverse tangent of y
Yeah, so this would be inverse tangent of y over x, which is y is 1 over rad 3. So we're at 3 over 3. What is tangent rad 3 over 3? What angle?
30 degrees of 5
Yeah,
6.
5 over 6. So these, again, none of these are new. We know all of this. We know all of this from way long time ago. We're just using them in different ways. Yes?
We wouldn't put plus or minus 2, right? For all.
No. If we did, we'd have to change the angle so we actually end up at that point. So we normally take r to be positive. We could let r be negative, but no reason to. Okay. On part B, this one over here, 4B, do you guys see a way to make x squared plus y squared show up? Because if I see x squared plus y squared, that kicks so much ass. Can I make x squared plus y squared show up? I would just add y squared, right? So x squared plus y squared is
R squared.
r squared. And what's y over x?
Tangent.
Tangent theta. Is there any more x's and y's left? Right here. Are there any x's and y's? Right here. No, I'm done. I got r and theta. So I converted from rectangular to polar. So, I know that was a little quick, but that's the last new stuff. Let me give you the practice final. We can do more of this. I just want to talk about a few problems on here. I'll have the answer key for this on Wednesday. Okay, alright. So, this is just like any other practice test, except of course it goes with the final exam. But I'm gonna have an answer key. You don't have to do any of this if you don't have time. This is just if you have time. Another way to kind of study. Let me see, was there, at the very bottom here, I did give you a polar problem. Here's a couple more. I'm definitely giving you a problem like this. This should be relatively, everybody should just be able to do this. I don't know about these. I don't know. We'll see. We'll see. But definitely still do the homework. Then everything else should look very familiar. The one question people always have trouble with is, how do I know if there's going to be a second triangle, right? And I know the book has a very strange way to tell. It's really kind of silly, but does anyone remember how to tell if a second triangle exists? So let's do the first step in part B. How do I know that part B is law of sines?
Because you're given sine C and C.
I can make a complete ratio. I love it. So what's that ratio I can make?
Sine of 51 degrees over 12.
Yeah, C stuff equals
Sine of B over
B stuff. I love it. How do I solve for angle B?
multiply by 15.
Yeah, multiply by 15.
You take the inverse sine.
And then take the inverse sine. Yeah. So plug all that stuff in your calculator. So if you have a calculator, plug that in real quick. This is a 15, trying to be a 15 there. Make sure, let's see, make sure we're in degrees, yes. That's what I love. How do I know it's supposed to be in degrees? Because freaking degrees, okay. So inverse sine of 15 times sine of 51 divided by 12. That is B1. So the minute you get an angle from law of sines, and you only had one angle to begin with, that's where you might have the situation where it could kind of come in and still make another triangle like it did on the board that one day, right? How do I check that? I check it the same way every time.
Add B and C and subtraction 1.
No. That's how you would get angle A for the first triangle. I want to see if a second triangle exists. So what I would do is, what's 180 minus 76.27?
123.7.
103.73.
0.73.
I like it. What's 103.73 plus 51? Will it be bigger than 180? No. Will it equal 180? No, it's less than 180. Therefore, a second triangle exists. So this would be B2. So if I'm doing this problem, I'm going to get B1. I'm going to check to see if a second triangle exists. It does. Damn it. I'll come back. I'll get A1. I'll get side A1 for the first triangle. Then I'll worry about the second triangle. And if I just do it very organized, I actually end up doing the exact same work twice. Just one with the ones and one with the twos. Before I forget. Now, if you want to, we could do that whole problem right now, or we can wait for Wednesday. You guys can try this out. I sort of want to let you guys try this out if you want to. Yes.
So for C2, would you add the 103.73 plus the 51?
Yeah, totally.
Subtract it from 180.
So, no, not to get C2. C is 51. C1 is 51, C2 is 51.
Okay.
Because C is set. So to get A1, I would do B1 plus C and take that away from 180. To get A2, I would take B2 plus C and take that away from 180. I have two separate triangles. So the way I would solve this problem, okay, I would do this work, and it would lead me to B1 is 76.27. Then on the side I would go, does B2 exist? Yes, because that, with that, leaves room for a third angle. If that was 143 plus 51, bigger than 180, there would be no second triangle. Then how do I get A1? Well, I just do this plus C, take it away from 180, because now I'm living in that first triangle. Right? So whatever the shit that is, 127, so it'll be 52.73, doesn't matter, Jeff. And to get A2, I do the same thing. I take the angle I know, the angle I've got here, I'd add them, take it away from 180. That's, of course, what the other angle is in that triangle. So you completely, so I wouldn't even look at the second triangle. I would actually finish the first triangle out, and then I come over and do the exact same work for the second triangle, just using that angle. Yes?
For number 4 on the practice test, B, I'm pretty sure it's half angle, right? Because if it's half angle, then when you multiply it by 2, it'd be 230, and that's not a thing we know.
Yeah, what was I thinking? Oh, I think that's supposed to be 105. Thank you. Make this a 105. I didn't mean to make it so weird. Because what's twice 105? 210. And that's one we know. Yeah, I'm not sure where my brain was at. So make 4B secant of 105. And then like you said, Thomas, that'll be a half angle. Because twice that we know. I think I was trying to make it, let me think. Oh, I know what I was trying to make it. Because you could do this two different ways. You could do half angle, or isn't this 45 plus 60? Could you do like 1 over cosine of 45 plus 60 and use the sum formula for cosine, right? Cosine, cosine, minus sine, sine.
45 and 60 is still 105.
Say again?
45 and 60 is still 105.
That's what I say. So you could use 45 and 60. You could use the summation, the addition formula for cosine. All right, I think that might be enough for today. So on Wednesday, I'll have the answer key for this. It'll be wide open to questions. We'll review for the final. Stop at section. Oh, let's see. Polar. 8.2, I think it is. Let me see. No, I'm wrong. I might be right. Let's see. 8.5. So you can stop at section 8.5 for homework. That's the polar stuff. You guys with me? If you remember, I made like 8.3, 8.4, some other stuff as extra credit. You guys remember that? Yes.
So we including 8.5, right? We do 8.5.
Yes. Do through 8.5, yes. Yeah.
Can 860 extra credit?
Yes. 8.6 will be extra credit.